Welcome to our video tutorials for getting started with controllers from STW. In this video, we would like to introduce you to application programming based on STW's template application. We have seen in the previous videos of the series Getting Started how we can put the controller from the starter kit into operation and flash a prefabricated sample application onto the controller using openSYDE. Now we want to write an application ourselves that makes an LED of the controller flash green. For this, we need openSYDE, the target support package with the included template application, the development environment code blocks, and the compiler. So we start with openSYDE and a new project. We use an ESX3CS. We use the CAN bus and connect interface number 1 of the controller to the bus. We save our project and make sure not to use spaces and special characters in the path name. By default, various parameters are now preset, such as node ID 0 and CAN bitrate 125, which we leave as they are. We transferred these settings to the controller. For this, we use the device configuration, which we have already shown in the video, getting started with CAN communication between PC and controller. This was successful. So we can also communicate with the controller in this project with these settings via the CAN1 interface. For the controller, we now want to create a programming project based on the template application from STW. We could do this by manual copy operations, but we let openSYDE support us. For this, we return to the system definition. There is no data block defined yet for the ESX3CS. If we import the openSYDE TSP from the controller's TSP, openSYDE will create the programming project based on the STW template application in addition to the data block. We import the openSYDE TSP and thus get the data block for the controller. We can determine the path to the programming project that openSYDE creates for us here. Let's take a closer look at the data block and what else openSYDE has done by importing it. The name of the data block can be changed. It is a programmable project. openSYDE can support this with the generation of source code for the realization of certain features. We do not go into this feature set in detail here. We present this in detail in the series of the openSYDE videos. Under this path, openSYDE has created the programming project for the IDE. We compare this in parallel with the Windows Explorer. Here is the whole project based on the STW template with the subdirectories for the project file, libraries of the BIOS of the controller, programs, etc. This principle underlies all openSYDE TSPs. Even if the IDE logic CAD is used as with the controllers of the 4th generation, instead of code blocks as with the 3rd generation, an empty template application with the matching IDE of openSYDE is always created by the import. Under this path, the hex file is stored by the IDE and the compiler. It already exists and will be overwritten every time we rebuild the application later in the development process. In this field, we can still enter the command line matching the installation on the PC to start the IDE from openSYDE. First, the path to codeblocks.exe. And then the parameters for the project file from the programming project. We can now start the IDE from openSYDE, which also immediately opens the project with the template application. Let's commence with the programming now. For application development, we will often need the user manual of the controller. CodeBlocks offers the possibility to include such external manuals in addition to the help of the IDE under the menu item Help. We therefore link our manual for the ESX3CS there as well. We had set ourselves the task of making the user LED of the controller flash green based on the template application. But first we look at what is already prepared in the template application. We see the included libs for the BIOS of the ESX3CS, the OpenSide server, and the LWIP. This provides us with the command set for the controller, the connection to the OpenSide software, and the operation of the Ethernet interface. In the subdirectory src, we find the template program main.c. It starts with includes for the BIOS and the OpenSide server. Then queries for the use of the hardware configurator and Ethernet follow. There is a detailed video about the hardware configurator in the OpenSide series. We will refrain from delving into the intricacies of this feature and the Ethernet configuration options at this time. In this program, some defines and global variables follow, which are needed for the correct startup of the application on the controller. In the implementation section, we see the initialization of the controller, and then the initialization of the CAN interfaces and the Ethernet interface. This is followed by the initialization of the OpenSide server and the hardware configurator. Subsequently, the task system undergoes initialization, and upon successful completion without errors, the main switch is activated to provide the outputs. Subsequently, the main loop initiates, activating a function to manage the LED while continuously monitoring the ignition signal and systematically shutting down the system when the ignition off signal is detected. We already know how the function mHandleLED works. It is the well-known color change of the user LED on the controller from red to green. If we now want the LED to flash green instead, we can adapt this function accordingly. The function uses the BIOS functions xsys getTimeMS and xsys setLED. We look up in the user manual how these BIOS functions work. We can tell from the xsys name that these are system functions. xsys getTimeMS returns the system time in milliseconds. xsys setLED enables the control of the user LED. We have the flexibility to toggle it on or off, as well as to establish specific color tones, whether fixed or intermediate, by assigning numeric values ranging from 0 to 100. Back to the code. Through the if statement, after 1000 milliseconds, or 1 second, the Hue8CANT counter is incremented. By calculating the remainder of the division of the counter by 4, the next value of the array O16 blending is selected every second, resulting in red, orange, yellow, and green. This selected color is then set using the xsys setLED function. We customize the routine, no longer incrementing the counter every second but toggling between 0 and 1 instead. With each toggle, we turn off the LED or switch it on with the color green, following the commands outlined in the user manual. In this programming scenario, the array and its associated programming with axis set LED are no longer necessary. With that, the programming task is complete. Now we need to build a new application and flash it onto the controller. Before we build the new application using the compiler, we first save all the changes made. Subsequently, we make sure that we build the release target. Thereafter, we start the build process, either via the menu item under Build or via the button. We observe the progress in the log window of the IDE. The build process was successful. By creating the whole project with OpenSYDE, the hex file we just created is already in the right place, so we can switch directly to OpenSide and flash the application to the controller. We start the update mode, and OpenSide recognizes that the new application is not yet on the controller. We can see from the behavior of the user LED on the controller that the currently running application changes the color of the LED. Let's start the update process. The new application has been flashed successfully. We exit the update mode. This will reset the controller and our new application will run. We check the user LED on the controller and recognize by the green flashing that our programming was successful. We've successfully written and compiled our initial small-scale application. After flashing it onto the controller, we've verified the outcome. With this accomplishment, we're ready to delve into developing more intricate applications. For a more in-depth understanding of utilizing the OpenSide software platform and programming tailored applications, we recommend checking out the OpenSide video series. I wish you the best of luck with your STW controllers.